Alright guys, so first things first, there's a couple things I want to go over before we even start this. I wanted to let you guys know I'm not going to do all of the math to get the answers because I don't want people to just copy the answers. Not that I don't trust you guys that you would just come and copy the answers, but I want to make sure you understand how to do it because it's the same calculations you're going to be doing in the lab. So with that in mind, I'm mainly going to show you how to set everything up, and I'm only going to do calculations that are necessary to help answer other questions. So we're going to go ahead and get started. First thing I do when I'm doing my labs is something silly. Write my name on it. Just don't forget to ever do that because it's kind of hard to get credit if you don't write your name on your paper. So, okay. To a graduated cylinder with a mass of 89.22 grams, you add ethanol until the 25 milliliter mark is reached. The cylinder now weighs 108.95 grams. What is the density of ethanol? So there's a couple things you're going to get from this in order to calculate your density. First thing you're going to grab is the fact that the graduated cylinder weighs this amount, and then it weighs this amount, and you're also going to grab that you have 25.0 milliliters of your ethanol. So we know that density equals mass over volume, right? So in this case, we want to know the density of ethanol. So we need to find out what our mass is, and we already have our volume right there. So let me make sure that this is a lot clearer. So we have our volume. Let's figure out our mass. So our mass is going to be the final weight of the graduated cylinder minus the graduated cylinder itself. And the reason we do that is because we only want what the ethanol itself weighs. So 108.95 grams minus 89.22 grams will give us, there's a 3 there, there's a 7 there, and then here, oh my gosh. I just want to make sure I don't give you guys the wrong math. So 19 is what you should get there. So that tells us that mass equals 19.73 grams, right? And we have our volume over here, which is the 25.0 milliliters. So divided by 25.0 milliliters. And I didn't realize how much that color was different. But okay. So this is going to give us our density, right? Because we know that density is mass over volume. So in doing the calculations, density equals, all I wrote down there was ethanol, 19.73 divided by 25.0 equals 0.7892 grams per milliliter. So we have our density as a mass over volume. So everything checks out there. Now, as far as sig figs, we draw our line here. Let me use red to draw it. So with the addition, we would have 1, 2, 3, 4 sig figs, as we have right here, 1, 2, 3, 4. But over here, we have 25, and that's a 0.0, so that's 3 sig figs. So our overall answer should have 1, 2, 3 sig figs, meaning the density of ethanol equals 0.789 grams per milliliter. This would be our final answer there. This one, number 2, I'm going to show you how to set it up, but I'm not going to do the actual answer. So, if we have our density, it says to use the density that we calculated, we know that that's a mass over a volume. In this case, we're given a mass and we want to know the volume. So we're going to rearrange this equation and we're going to go volume equals, we would multiply by volume on both sides and then divide by density. So it's going to equal our mass over our density. That should be ETH, the density of ethanol. So now that we've done it like I like to do, which is solve it with just variables and then plug in the math. So our volume is going to equal the mass that we're given, 5.00 grams, divided by our density, which in this case, our density is 0.789 grams per milliliter. That's going to cancel our grams and give us whatever milliliters. Another setup for this, if you prefer the setup to look more like stoichiometry, is you can go 5.00 grams times, you can use the density like this, 0.789 grams over 1 milliliter, and the grams would cancel, giving us whatever milliliters. And for sig figs, you have 3 sig figs, so your answer should have 3SF. 3SF. Okay? And if you want, you can comment on the bottom of the video and put the answers if you really want to do that, but I encourage you guys to all actually do this, okay? Just thought I'd throw that out there, though. Okay, same thing here. Same thing in number 1. To a graduated cylinder that has a mass of this, you add mercury until the 5 milliliter mark is reached. The cylinder and contents now weigh this. So we know our mass is going to equal 103.89 grams minus 35.89 grams equals however many grams. And I'm going to do the math on this one. And so mass over volume, right? So density of mercury equals. We also know that our volume is this. And so our V equals 5.00 milliliters. Trying to keep the colors in line because as you can see over here, I'm just sliding a little scale. I haven't set any presets. Okay, so all we're missing here is our mass to solve for our density. So this is why this question was set up, because if you put it in a calculator, your answer is just going to be, because I can't do simple math in my head, 68 grams. That's what your calculator is going to give you. Now keep in mind, if we drew our line, we actually have 68.00, right? The line would be right here. So you have 4 sig figs right there. Now overall, it's not really going to affect you that much because your volume is still in 3 sig figs. So that's going to be the lesser of your sig figs anyways. But if you just wrote down 68, that would give you 2 sig figs, which means you would put your answer in 2 sig figs, and that's not what you want. You want an answer in 3 sig figs. So that's why they put this question here. to see if you know where you should be as far as sig figs. And if they see 2 sig figs, they know what happened. So remember, 3 sig figs for the answer. So 68.00 grams, which equals divided by 5, 13.6 grams per milliliter. That's the density of mercury. So we have a density. So number 3 says, use the density from number 3 as a unit conversion to calculate the mass necessary to provide 1.50 mils of mercury. So we know we have density, and that's going to be the mass over the volume, right? We're also given a volume this time, and we want to solve for mass. So if we rearrange this equation, we're basically going to multiply by V. Mass is going to equal the density of mercury times that's supposed to be a V, the volume of mercury. So plug in numbers here. You have 13.6 grams per milliliter times the given information of 1.50 milliliters, and your milliliters are going to cancel, and you will get an answer to how many sig figs? You said 3, ding, 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 you're correct. 3 sig figs, and then your unit's going to be grams, right? Because your milliliters cancel. If you want to see how it would look stoichiometrically, I don't even think that's a real word, but 1.50 milliliters times 13.6 grams over milliliters. So if you set it up like that, it would look like that. These would cancel, and that gives you grams, again, to 3 sig figs. All right. So if you've come to the SI sessions, we've done a warm-up problem like this, and here it comes again. So we have a rectangular piece of glass that has a thickness of this, and it's 7.61 centimeters by 7.68 centimeters. So you're given everything you need right there to solve for the volume, because you know the volume of a rectangle is going to be length times width times height. One thing to pay attention to there, oh, by the way, we're solving for density, so the density of glass is going to be mass over volume, and we're given a mass, so that's not anything to worry about there. But if you do notice, that's in centimeters, that's in centimeters, and that is in millimeters, this one right here. So we're going to need to change that. Number one, density is usually given in like grams per milliliters or grams per centimeters cubed, kilograms per meters cubed. I've never seen a density in millimeters cubed. So you wouldn't turn these into millimeters, though technically it would be correct. It's not what's normally asked for. So we're going to go ahead and find out our volume right now, but I'm going to write the mass down really quickly. This mass is 35.303 grams. And then let's go for our volume. So our volume is, we'll go 2.2 millimeters times, so remember, as I always say, we don't want millimeters, so millimeters on the bottom. And we're going to go to our base unit of meters. So for every meter, there's 10 to the 3 millimeters. Now we're trying to go to centimeters. So we don't want meters, meter on the bottom and centimeter on the top. The smaller unit is the centimeter and the bigger unit is meter. So for every 1 meter, there is 10 to the 2 centimeters. Now you're saying, well, why didn't you just divide the number by 10? You could do that, but this guarantees that you will not mess up at all, because you're going back to your base unit and then you're going to centimeters, to the unit you want to go to. And though you basically are dividing by 10 in the end, this is the safest route to take. Until you're just amazing at it, I would do this. But enough about that. So yeah, as you can see, you divide by 10, and that's going to be centimeters. Cool. So we have that times. Let's do this down here. All right, you know what? Sorry for this. I'm just going to stack them, okay? 7.61 centimeters times 7.68 centimeters. Now remember, it's not like addition. We're doing centimeters times centimeters times centimeters. So that's going to be centimeters cubed. And as far as the number, 0.22 times 7.61 times 7.68 gives us 12.857856. And how many sig figs would we want that to? If you said 2, you're correct. It's this one right here. So remember, don't round yet. Keep that number in your calculator. But you do need to know that's only 2 sig figs. So that's going to be divided by our newly found volume, which is 12.85 7856 centimeters cubed. And you don't need to write all this down. I'm just doing that because that's what I have right here in front of me. So 35.303 divided by answer equals, I get an answer of 2.7456 grams per centimeter cubed, which is going to be equivalent to, what do you guys think? Yep, 2.7 because of sig figs, grams per centimeters cubed. That would be our final answer right there. All right, and that's from the book, or that just tells you that it came from the old book, so we don't need that space. Continuing on, I know it's already a 20-minute video. I'm sorry. If you guys want to put timestamps on where each question's worked out, you can do that. But I just don't have the time for that. Really, give me 2 seconds. I'm going to look up the density. All right, so super cool. It stopped recording and I had no idea. So let's get back into this. We were at number 6. And like I said, if you guys want to make a timestamp on this stuff to tell where everything is, feel free to do that. That'll help out a lot. But so it missed this part. Number 6, a 24.3 gram irregular nugget displaces 1.26 mils of water. Is it likely that that nugget is gold? So what you're going to do is you're going to take your mass right here over your volume and find the density of this irregular nugget that you really hope is gold so you could be super rich. So you're going to do this part right here. 24.3 grams over 1.26 milliliters equals some number grams per milliliter, which you know is equivalent to some number of grams per centimeters cubed. When I went online, this number right here is what I found. 19.32 grams per centimeters cubed. That's the density of gold. Au is the atomic symbol for gold. in case you didn't know. So you'll find this number right here, and you will compare it to if it's approximately 19.32 or 19.3 or even probably 19.12, then you could go with this option right here. Yay, it's gold. I'm super rich because 24.3 grams of gold. Yeah, you can buy yourself something nice. If it's not, if it's nowhere near it, then no, it's not, because the density does not equal the density of gold. With this being said, you're just gonna look and compare them. You know, they're gonna be within reason. Say you get 19 for an answer. Remember, you want your answer to 3 sig figs, by the way. 3SS. If it's not, or if it is close to it, you still can't definitively say it's gold, because there's probably other things out there that have the same density. But you could also kind of lean towards, yes, it is gold, based on the way it looks, it feels, you know, how it feels in your hand. You know, gold is a yellowish color. It's bad explanation, but it's golden. But yeah, so that's how you would explain your answer. It would be one of these two. And make sure you include "I'm rich" in your answer, because that's the most important part. Number 7. So right here, you couldn't determine the density of sugar by water displacement, because when you put the sugar into the water, it dissolves, right? If you don't believe me, go try it right now. Not all of it's going to dissolve if it's cold, but it's still going to dissolve, and that's going to change stuff. So that brought me to this right here. No, you can't, because it dissolves. Keeping this in mind, suggest a method that could be used. Now, I want to have you guys think critically about this, but I will give you some sort of push, and if you want more, if you want me to help explain it to you, just come and talk to me before lab at some point, even during the essay, that's fine too. Which, remember, is from 3 to 5, about 3 to 5, and it'll be, he just emailed me today to give me the room, so I gotta check that. But the push in the right direction is, just because it dissolves in water, does not mean it dissolves in everything. Let me go and quiet this dog. All right, and the final question, and I know this video is ridiculously long. I am sorry, but I want to make sure everything's thorough. So, water and antifreeze, which is ethylene glycol, mixtures have densities listed in the table below. Plot the density on the vertical axis, that's this one right here, and the mass percent of ethylene glycol on the horizontal axis, aka the y-axis, that's right here. Yes, and I think that's about it, right? Yeah, and then determine the percent ethylene glycol of an ethylene glycol water mixture that has a density of this bad boy right here. And remember, just like always, we're going to go ahead, we're going to plot everything first, and then we're going to answer the question. So the question basically is saying, let me write it in a different color over here. When density ET gly equals 1.030 grams per milliliter, what percent is ethylene glycol? I have no idea why I can't spell. That's basically the question they're asking. But in order to answer this, you're going to need to plot stuff. So the first thing I did ahead of time to shorten this video is I plotted all of these right here. So you can tell just by looking at these two, it's the easiest to tell. It's going up by 0.01 every time, right? So from here to here, 0.01 difference. And if you want to know what it actually is, you could easily take this number minus this number. So you would go 1.010 minus 1.000 is going to give you 0.010. That's what every thick line is. Now, the other thing we need to know is what every single line that's in between is. So we're going to use this as an example again. If we know the difference between the two is this, right? 0.010. So 0.010 divided by, from here to here is 5 lines. 1, 2, 3, 4, 5, right? So divided by 5 gives us, and we're going to go ahead and do some math there. 1, and like I've already written, 0.002. So that means every single line in between there is 0.002. So like I said, I wrote all these out, and when we're looking at these, we're going to plot the points as best we can. It's going to be harder for me on the computer than it is for you guys because you'll have rulers and stuff like that. So, okay, so we're going to ignore this part because honestly, it doesn't mean anything to us right now. But oh, the last thing too, anytime you're doing these, you wanna put a title on each axis. So the density in grams per milliliter, percent ethylene glycol, and then the title of it is it's y versus x. So density, and I should have put grams per milliliter versus percent ethylene glycol. So back to where we were. 0% ethylene glycol. So treat these as xy coordinates. And then 0.998. Well, that's going to be, we go down 0.002, because that's what that says. It's going to be like right here. So that'll be my first point. And my points are going to be bigger than your guys's. And it's going to be a little bit different than your guys's. You should just make smaller points. All right, so the next point I have at 10%, 1.011. And sorry, you could fill these in, right? You know that this is 10, so halfway should be 5, and each one's going to go by 5s. So, okay, at 10%, I have 1.011. So that's going to be like right there, right? Because this is 0.010, this is 0.012 right here. So yeah, and it goes up from there. Okay. Let me just double check something. 3, so yeah, okay. So the next one. Yeah. Okay. So we've done this one, we've done this one. Let's do this one. At 20%, we have the number 1.024. So 022, 024. We're right there. That one's done. The next one at 32%, we're at 1.040. So if each one of these is 1, this would be 2, Okay, so 30 and then 1.040. It's going to be on this line, 31, 32%. It'll be right there. So check. And then 40%. So that's this line right here. It's going to be 0.051. So that's right there. It's in between the two lines, right? And then for 48, so here's the 45 line, we're going to be at 0.067. So 2, 4, 6, and then we're at 48%. So 5, 6, 7, 8. We're right there. Okay, so this is one of the more important parts. You want to draw a best fit line. And I don't know how well I'm actually going to be able to do this on here. But, yeah, I don't even think there's a straight line. Oh, here, draw a straight line. Okay. So what you want to do is you want to draw a line to where there's an equal amount of points. You have 6 points here, right? So you want to have it to where 1 point, 2 points are on the line, 2 points are above the line, and 2 points are below the line. So it looks like it's probably going to be maybe somewhere like this. So let's see. Something. So I would have this point and like this point right here on the line. And please draw yours better than mine. Maybe that's pretty bad. So just don't connect the dots, basically, is what I'm trying to say. You don't want to do that. In my case, just to kind of get it where it needs to be, I'm gonna have to kind of do something like that. But you'll have a ruler, and you always draw your lines with a ruler, by the way. And that's how you'll do yours a lot better than mine. So I have mine, and if I was looking, we would say that, like this is above the line, and the other one would be probably, this one might barely be above the line if I was looking. This one would probably be a little below it. Maybe, I don't know, maybe this one's below it, and then this is on the line, and this is on the line. So, like I said, it'll look a lot better on your page. But don't connect the dots. That's key. Okay, now we're going to answer the question. So we want to go over to 1.030 grams per milliliter and find out what the percent equals. So coming over here, and looks like mine crosses right there. Now yours might be different. Actually, it should be different. So looks like I'm going to go right here. And you would draw like a dashed line to this. And then I'm going to go down. Something similar to that when you do it. And then when I look at mine, mine tells me I am at 24, or that's supposed to be a 4, 24% ethylene glycol. So I would say my answer is 24%. I'm almost 100% positive that that is not the answer you are going to get. So just make sure your answer is concise with your information. Let me write again. The key things you want to do is title graph. You also want to label axes. with units too. You also want to, oh, and the title of the graph is y versus x. You want to plot points. Let's erase that. You don't want to do that. You want to label your axes, and then you want to find value of each line. By that I mean how we figured out that these go by 0.01 and the little lines go by this. So 0.002. Then you want to plot points, and after that we want to draw our best fit line. Put it in another color for a reason. You don't connect the dots, and I'll write that in red right underneath. Do not connect dots. When you're drawing your best fit line, again, approximately equal numbers of points above below and on the line. And the final thing you want to do, the thing that you've been doing everything for, is answer the question. All right, guys, I know that's like 45 minutes. Sorry about the dog thing in the middle of it. But yeah, I hope that helps, and I'm going to upload it now, put it on the page. I'll send out an email that has a link as well, and a link to the page, and I'll also be putting the room number on the page as well. So I'll see you guys on Tuesday. Study hard. Good luck on everything, and I will, like I said, see you on Tuesday. Bye.